Today we're going to talk about the concept of limits, or another way to think of limits is kind of like an end behavior in this case. Basically, as an input value approaches some number, we want to know what the output value approaches. Typically, limits are written in this form. You'll find the limit of some given function, so here's our function f of x, or f of n in this case, and then they're going to tell you what the variable value goes to. So in this case, the variable n goes to infinity, and I want to know if I put in a very big number to n, what is the output going to look like? Well, we can see that if I have 1 over 2 to the infinity, or 1 over a very big number, this denominator goes to 0. Or I'm sorry, this denominator goes very big, so 1 over a very big number is going to be pretty much equal to 0. So that would be the limit in this case of this function. In our next example, you're going to see now that we have a situation where we have variables in both the numerator and denominator. In this case, where we have polynomials in both the numerator and denominator, there's a format that we want to use to find the limit algebraically. We can kind of guess at what it would be, but we're going to go through this format. So when you have a numerator and denominator that are polynomials, you want to find the greatest degree of the denominator and then divide that term into all the terms. So in this case, we look at the greatest degree in the denominator, which is a degree of 1. So I'm going to take and divide n to the first into every term in my problem. So I have the limit as n goes to infinity of 3n divided by n plus 6 divided by n over n divided by n. I'm going to take and reduce this, which gives me the limit as n goes to infinity of 3 plus 6 over n over 1. And now what I'll do is I'll take and plug infinity into any remaining n value. In this case, I have 3 plus 6 over infinity over 1. 6 over infinity is basically going to go to 0. So as my answer, I'll have 3. And the reason why we just didn't go through this in the first place is you can't do necessarily any kind of math with infinity. If I had 3 infinity plus 6 over infinity, infinity is really undefined. You can't get your hands around it. So 3 times infinity is undefined. In theory, we could make the guess the answer is 3, but this is the mathematically appropriate way to go through and find those limit values. So let's look at our next example. In this case, polynomial on top, polynomial on bottom. The biggest degree in the denominator is n squared. We're going to take and divide n squared into each of our terms. So we go up here and say I have the limit as n goes to infinity of n squared over n squared minus 3n over n squared plus 4 over n squared over n squared over n squared minus 1 over n squared. And I'm going to reduce all of that. So we'll find the limit as n goes to infinity of 1 minus 3 over n plus 4 over n squared over 1 minus 1 over n squared. When I pop infinity into all of this, so I'm taking the limit as n goes to infinity as the value of the input goes to a big number. What's the value of the output? I have 1 minus 3 over infinity plus 4 over infinity squared over 1 minus 1 over infinity squared. And as you can see, anything over infinity is going to be a very small number, so that goes to 0. This will go to 0, and this will go to 0. Thus, the limit of this function is going to be 1. Let's move to our next example. Now in this case, we have once again polynomial on top, polynomial on bottom. We see our greatest degree in the denominator is n squared. I'm going to divide everything by that. So we'll say the limit as n goes to infinity of n cubed over n squared minus 8n over n squared over 900 n squared over n squared plus 100 n over n squared. So now once again, we'll do some reduction. Have the limit as n goes to infinity of n minus 8 over n over 900 plus 100 over n. So in this case, you'll notice as we let n go to infinity, we'll have infinity minus 8 over infinity over 900 plus 100 over infinity. Anything over a very big number pretty much goes to 0, so these two will go to 0. The problem we have now is we have a very large number over 900. This is really undefined, so we say this has no limit. That's pretty much all we've got for you today. Here are the questions I'd like you to answer, and we'll see you tomorrow.